Today, I'm going to try building a working analog clock in Lego Fortnite Odyssey. I've been thinking about this for a very long time, ever since I made my first version of gears over a year ago when I used tires as the teeth, and we didn't have swivels yet. Also, just as a warning, there will be a little bit of math in this video towards the end. So the first thing I wanted to test was a gear connected to my old bearing shaft design, and it works pretty well. After that, I made the same thing, except the shaft in the middle is also connected to a gear, so there can be two spinning clock arms. I wasn't quite sure how I was going to make the hour hand, and for some reason I thought it would work better if I made it go around the outside of the clock face. So I tried making a few designs, two of them broke pretty easily, and I was starting to worry that I wouldn't be able to make this work. This one kinda seemed like it might work, but before I put a gear on it, I thought of a better idea, and I decided to try that instead. So I made a wider shaft that fits around the center shaft, and it worked. So then I put all of the pieces together, and surprisingly, the three-handed clock prototype worked. Then I was finally ready for a few more tests. I was originally planning on stacking the gears vertically, but the vertical stacked gear train didn't work for some reason. After that, I needed to figure out how long it takes for the controllable swivel to make one full rotation, so I could figure out how to make the gears spin at certain speeds. So I assumed it took 1 second to spin all the way around, and built a gear train that would make the last gear take 60 seconds to make a full rotation. My assumption turned out to be correct. So the way it works is that all of these gears have a small gear the size of the driver gear on the front of them, so you can then multiply the gear ratio for each. The first one is double the size in teeth, so multiply by 2 and you get 2 seconds for a full rotation. Multiply by 3 for the next one to get 6, 2 for the next one to get 12, and 5 for the last one to get 60. After that, I connected it to a one-sided gear, and from that to another 5:1 ratio gear, which causes both gears to spin at the same speed. Another important thing I learned while testing this is if you line the teeth of the gears up, it will get jammed, so you have to place them one notch away from being in line. After all that testing, it was finally time to put it all together. I didn't keep track of how long it took to build, but I know it was several hours. Especially since I placed a few gears slightly off and had to break them off and fix them. I didn't want to have to record for a few hours to show all of the hands moving, so instead of a 60 second by 60 minute by 12 hour clock, I just multiplied each hand by 15, so 1 minute or a full rotation for the second hand is 15 seconds. Then 15 of those minutes for the minute hand's full rotation, and 15 of those hours for the hour hand. If that's confusing, sorry, it's 15 by 15 by 15. When I first tested the clock, the second hand got stuck for a second on the 7, about half the time, but when I logged back in later, it seemed to work fine. I was super worried while I was building it that it was going to jam, but it works pretty well, and I think it looks really cool.